Hello. Today we're going to spend another day doing linear inequalities 1.5 day 2 notes. So yesterday we talked about the different types of notation, interval and set notation. Intervals, if this helps again, have the infinities. Sets have the squiggle looking things. So interval notation is left to right where is shaded on your graph. So for this first one here, it's shaded to the left for forever. Because it's pointing that way, so that makes it negative infinity. And then it stops shading here at -3. So my interval notation is going to be negative infinity to -3. The infinity is always going to have parentheses. And then the number depends on the circle. Since it's an open circle, it's going to be a parentheses. Versus the next one, it starts at negative infinity for number 2, but at your number, which is 43, since it's a filled in circle, it's going to have a bracket for that one. Number 3 is pointing the opposite way, which means my graph starts at point 3, but it's shading to the right for forever, which is positive infinity. So my interval notation is going to be 0.3, comma, infinity, where infinity has a parentheses, and the 0.3 is filled in, meaning it has a bracket. For my set notation for these ones, I'm going to start with my set with x such that, and then I need to figure out what this solution up here actually represents. So for this one, I'm trying to compare x to -3, and since I've shaded to the left, that is highlighting all of the numbers that are smaller than -3. So my solution for that is -3, and then I close my set bracket. For the next one, it's the same type of idea. I'm going to open up x such that, and then I look at my shading. It's once again to the left. So if I'm comparing x to 43, I want all of the numbers smaller than 43, but now I notice the filled in circle, so it's also smaller than or equal to. So I write my answer, x is less than or equal to 43, and then I close my set bracket. For the last one, I'm going to go ahead and open up x such that. I'm comparing x to 0.3, but I shaded all of the numbers bigger than 0.3, but I also shaded in 0.3. So it's going to be x is greater than or equal to 0.3. So that's a reminder of the different notations. Today we're going to be focusing on more solving ones and then writing your answers in those different notations. So the goal of solving is to get your variable by itself. For this one, we're going to go ahead and subtract 15 from both sides. We get -3x is greater than -30. Always bring down your inequality. Do not write equals. You need to make sure you have your inequality there. Then you'd look at this and you'd say, hey, normally I would divide by -3. So here's where you have to pause, and here's going to be this big concept for today. If you are multiplying or dividing by a negative, if you are multiplying or dividing by a negative, you must switch your inequality. You have to switch your sign. So we're dividing here by -3, which means we get x and we get +10. But this greater than here has to become a less than. Okay, so it's if you are multiplying or dividing, and specifically the number you're dividing by has to be the negative, then you switch your sign. So looking at this solution then, we're going to put 10 on the number line, and it's going to be an open circle, and you're going to want to shade all of the numbers that are smaller than 10 or less than 10. So it should be shaded everything to the left. For your graphs, I'm totally fine if you do it above the graph, or even if you wanted to do it on the graph. All of those represent the same thing, so that's totally fine. Your interval notation then would be -infinity to 10, and 10 would have a parentheses. Your set notation is x such that x is less than 10. So let's go ahead and try this next one. We're going to solve it like we normally would an equation. So we're going to distribute the 3. We get 6x minus 6 is greater than 10. And now we want to get x by itself. So I'm going to go ahead and add 6 to both sides. When I add 6 to both sides, I get 6x is greater than 16. So I'm going to divide by 6, and you might be saying, okay, hold on a second, now I'm dividing. I have to see if I switch my sign. The number I'm dividing by is 6. Since it's just a positive number, you leave your sign alone. If this were a negative 6 and you would divide by negative 6, then you switch your sign. But because it's a positive 6 we're dividing by, you leave your sign alone. This is not a nice number. We're going to go ahead and reduce that fraction. It's going to become 8/3. So on our number line, we put 8/3. It's an open circle because it's not equal to, and we want everything greater than that, so shade to the right. So in interval notation, I'm starting at 8/3 and shading to the right, which is positive infinity, which has the parentheses, and so does 8/3 because it's an open circle. For this one, we're going to go ahead and do x such that x is greater than 8/3. Let's go ahead and try a couple more examples here. So for C, we're going to go ahead and solve this like we would an equation. We're going to multiply or distribute that -4. We get -12w plus 4 plus 6w is greater than or equal to 16. And once again, we don't switch our sign for this one yet because we're multiplying by -4, but we're distributing. We're not multiplying both sides of our equation by the negative. So now we're going to combine like terms. So we get -6w plus 4 is greater than or equal to 16. We're going to continue to solve. So we subtract 4 from the other side. And here's where now we're going to take and we're going to divide by -6 on both sides. And so alarm bells should be going off in your head saying this is the case. Here is where I switch my sign. It was greater than. I'm going to flip it around and now it's going to become less than. And it's going to become -2 there. So my final answer for this one is w is less than or equal to -2. So on my number line at -2, it's or equal to, so I'm going to fill it in. And I want numbers that are all less than. So I want everything to the left, which means my interval notation starts at -infinity and stops at -2. And at -2, you have a bracket. For your set notation, this one is actually w such that w is less than or equal to -2. So for part D here, normally when you look at this, you would say, okay, I'm going to go ahead and get rid of that -4. So let's do that. Let's multiply both sides by -4. The -4 is going to cancel out the divided by -4, so I'm just left with 7r minus 3. But here we multiplied by a negative to both sides of our equation. So my inequality switches from less than to greater than. So it's when you multiply or divide by a negative number, you switch your sign. On the right-hand side, you get -24. And then we continue to solve like normal. Now we're going to keep this as 7r is greater than -21. And I'm dividing by 7. 7 is a positive number. Even though the 21 is negative, I'm actually dividing by 7. So it's going to stay r is greater than -3. Which means on my number line, I have an open circle, and I'm going to shade everything bigger than -3, which is everything to the right. So my interval notation starts at -3 with a parentheses to the right, which is infinity. Set notation is r such that r is greater than -3. So that's how we solve these. Now, sometimes weird cases are going to pop up. So for E, this is one of these weird times. We're going to distribute. We get -6m plus 15 is greater than -6m plus 9. We would normally move all of the m's to the same side, but what's happening here is the m's are canceling out. And you're left with an inequality. 15 is greater than 9. So if all of the variables cancel out, you have to ask yourself, is this inequality true? And in this case, we have 15 is bigger than 9. This is true. When that happens, that means every single number, when we plug it in, we're going to get a true inequality. So every single number on my number line is going to be a solution. This is the case where we're going to get infinitely many solutions. You would show that by shading your whole number line. For interval notation, you're asking yourself what is shaded on your number line, and everything is. Everything to the left is shaded, everything to the right is shaded, and everything in between. So the left is negative infinity, the right is positive infinity, and those are both going to be parentheses. For set notation, when it's infinitely many solutions, we're going to define our variable such that now all real numbers should work. So we're going to say m has to be any real number. So m equals all real numbers. This capital R with a line through it stands for all real numbers. So that's the infinitely many case. Let's take a look at when the opposite is the case. So here we're going to distribute the negative 3. It's negative 6h plus 15 is greater than negative 6h plus 19. When we try to move the h's over, we get 15 is greater than 19. So we ask ourselves, is this true? We have no more variables. We're comparing 15 to 19. 15 is bigger than 19. No, this is not true. So this is going to be, if it's false, that's going to be no solution. Which means on your number line, nothing is going to be shaded because nothing is ever going to make it true. There's going to be no answer for interval notation. So we're going to do 0 with a slash through it. That means that's the null set, which means nothing works. In set notation, you're going to open up your bracket, but nothing for anything is going to work. So it's just going to write that 0 with a slash through it. That's the empty set, meaning nothing works. The last thing we're going to do is we're going to compare a word problem here. So we're going to order some roses online. We want it to be less expensive to order from florist A, which means we want the cost in florist A to be smaller than the cost for florist B. Now for both of these, I'm seeing that there's an amount per rose. So what I'm going to do is I'm going to say R is going to be the number of roses. So for florist A is $4.75 per rose, but unfortunately there is a $40 delivery charge. We're going to be comparing that to florist B, which has $5.15 per rose, but only a $25 delivery charge. So we are looking for where florist A is less expensive than florist B, so it's going to be less than. What we're going to do is we're going to go ahead and solve this inequality once it is set up. So I'm moving all of the roses to one side, or the variables to one side, and the numbers to the other. I get 15 is less than 0.4 R. So to solve for R, I'm going to divide by 0.4 on both sides. Since it's a positive, I don't have to worry about switching signs or anything. I get 37.5 is less than R. Which means if I were to try and compare it the other way, I want my roses to be more than 37.5 in order for this to be the case. For florist A to be the lesser expensive option, that means that Derek must order 38 or more roses in order for florist A to be the less expensive object. I'm just picking 38 because we can't order a half of a rose, so I just rounded to the next rose. So thank you very much for listening.